In the last module, we looked at the rules of inference. And now in this module, we are going to use those rules of inference to do the proofs. So let's look at an example. Here we are given H1, which is P implies Q, H2, which is Q implies R, H3, which is P, and the conclusion that we want to prove is R. Our goal is to establish a logical implication chain such that H1 and H2 and H3 imply C. So the hypothesis that we have, in this case we have three hypotheses. These are the three hypotheses that we have. We have to show that when all these three hypotheses are true, the conclusion is going to be true as well. We can do this by the truth table. This is in some sense easy, but it's not scalable in that if I had 50 propositions, then the truth table would take forever, and that's something we can't do. The second approach is using the logical implications that we saw in the last module and the rules of inference that we identified in the last module. So the truth table approach would be basically you take the three propositions we have, write down the truth value of each of the hypotheses. The thing that we have to worry about are only rows where all of these are true simultaneously, and in this case there is exactly one row where that happens, and in that case the conclusion is true. Now we are going to look at using rules of inference. So we are going to write the chain method or the proof chain that we want to write. I want you to go back and review the previous module to see what are the rules we have to follow. Maybe you want to have a copy of those slides with you as you're going through these slides. It will help you sort of follow what's going on. Okay, so here what do we have? We have three hypotheses, H1, H2 and H3. We have a conclusion C. So what's our proof chain? Our proof chain consists of a bunch of hypotheses and things that follow from that hypothesis. So let's look at our example, let's look at our proof. So in this proof, first thing that we have written is P. It is one of the hypotheses we have, and I'm allowed to write that by rule 1. Rule 1 said that I can write any hypothesis that I have, or I can write any tautology that I have. In this case, I am writing a hypothesis. Again, step 2 of the proof is P implies Q. Again, this is allowed by rule 1. The question you should ask is it allowed rather than how did I come up with it? How did I come up with it will require generally some sort of innovation. I want you to make sure that you agree with that I'm allowed to write these steps. The next step is I'm going to write the formula Q. The reason I'm allowed to write formula Q is because of modus ponens. Modus ponens, I'm going to use 1 and 2 as a way to apply modus ponens because I have P implies Q. Modus ponens says that I can write Q in that situation. In writing your own proofs, I want you to make sure that you write a justification for every step. The reason for that is because I want to make sure that you are actually following the rules and not just writing something that happened to be correct by chance. And also, when you are forced to write the reasoning, it's going to make your chances of the proof being right significantly higher. So here I have said I'm applying the rule modus ponens, and I'm using 1 and 2, that is the previous two steps, to get to this step. The next one, as you can imagine, I'm going to write Q implies R. I'm allowed to write this because of rule 1. It's one of the premises I have. Again, now you would imagine that I can use modus ponens to uh, get the next step, which is R, which happens to be my conclusion. This completes my proof. What I want you to be able to do with this proof is understand why each of the step is correct. I want you to also look at how we use the structure of this hypothesis to figure out how I'm going to write these steps. So the reason I wrote P and P implies Q first is because I know that I could get Q out of it, and then I can combine it with Q implies R to get R, etc. Let's look at another example. Here we want to prove if an integer n is odd, then n square is odd as well. Okay. First of all, what is our premise? The premise here is n is odd. Well, what does it mean n is odd? What is an odd number? I want you to think about that. What is our conclusion? Our conclusion is n square is odd. What does that mean? Now, generally, when it comes to questions associated with numbers, there is a meaning associated with what a number being odd is, what a number being prime is, etc. We will need to convert that into some kind of well-formed formula. So let's look at what does n is odd mean. Well, it means there exists a k where k is from the set of integers such that n is equal to 2 times k plus 1. That's what n is odd means. This means there exists a k, n square is equal to 2k plus 1. But now we have our premise, we have our conclusion, we can write the corresponding proof. Let's look at that. So we are given an integer n that is odd. This is something I can write by rule 1. I can write the meaning of odd. I can write as there exists a k such that n is equal to 2k plus 1. Now I can do some math. So in this case, I will write n square is equal to 2k plus 1 whole square. I'm going to take this 1 outside, and then I'm going to write the rest as 2 times something. So now I have written n square as 2 times some integer plus 1, and that means I can conclude that n square is odd. Once again, we have reached the check before you go ahead slide. I want you to make sure that you understood how we converted the hypothesis into the Boolean formula involving quantifiers, conjunctions, disjunctions, etc. I want you to make sure that you understood how we use this formula and the different rules like existential instantiation, universal instantiation, modus ponens, etc. in the proof. I want to tell you that this is a challenging topic. So If there are concerns where you're not able to understand what's going on with these proofs, it's important you ask us as soon as possible, because there are many people who are going to have these difficulties, and I will be going over in class with some more proofs, and hopefully those will clarify uh, the issues that you have with the proofs. Being able to write proofs of the sort that we just did in this video is an important goal of this chapter, and so I want to make sure that if you are not understanding something about how that proof was written, then make sure you discuss it with us.